Hi everybody. We've been using our trig functions, sine, cosine, and tangent,
and the inverses, the arcsine, the arccosine, the arctangent, to find either missing sides or missing angles from right triangles.
Today, we're going to try to figure out how to solve right triangles. Now when I say solving right triangles, it means a couple of things. One, we need to worry about the sides. We have to find all the sides. All three, A, B, and C in our picture over here. Remember, to find sides, you can use the sine, cosine, or tangent, depending on the information you're given. And we can also use, like we saw in class yesterday, if you have enough information, you can use Pythagorean theorem, a squared plus b squared equals c squared. That's only half of solving a right triangle. The other half of solving a right triangle is worrying about the angles. To find angles, well, we can use our, depending on the information we're given, we can use our arcsine, our arccosine, our arctangent, or we can use the fact that all triangles, all three angles, have to add up and equal 180 degrees. We looked at a couple of examples of both yesterday in class. Today, we're going to figure out how to do everything all at once. Here's our first example. Make sure you copy down this example
So you have something in your notes so you can reference later and study.
In this example, we need to inspect what we're given. Well, I'm given this angle right over here with A, that's 40 degrees. I'm told that this side on the bottom equals 6. Everything else, I don't know. We need to solve our right triangle. First thing I'm going to notice, I'm going to do the easiest thing in this triangle, and that's going to be solve for the missing angle. We know one angle is 90, the right angle. We were given 40. Those two add up, make 130. If I subtract 130, the two angles we were given, from 180, we should get what's left over, 50 degrees. That goes up here for angle B. 50 degrees. Now I need to do the work to figure out the other sides. Before I can use the sides, I'm going to have to use my trig functions. I need to make sure I label these appropriately. First thing we always want to do, use our right angle to figure out the hypotenuse. Use our 40 degrees, go all the way across from 40 degrees to figure out this is our missing opposite side. And luckily, we already know the adjacent. From here, it's up to you. Use SOHCAHTOA to figure out and decide which side you want to solve for and which trig function you want to use. Since I'm doing the problem, I decide we want to find h first, the hypotenuse. Looking at SOHCAHTOA, h comes up in the SO and the CA, the sine and the cosine. Now I have to decide which one will I actually use. Since I know the adjacent is 6, that tells me the adjacent, the hypotenuse, I'm going to use cosine. Let's write our new function. Cosine of our angle, 40 degrees, has to equal the adjacent over the hypotenuse. There's my setup. From here, it's just cross multiplication so I can solve. Put a 1 on the bottom so I get a proportion. Cross multiply. H times the cosine of 40 should equal 6. Divide by the cosine of 40 on both sides. 40. So we can solve for h. The cosine of 40's cancel. H equals, this is where my calculator comes in. That equals sign was a little bit ugly. H equals, plug it into your calculator, do a little bit of work. It comes out to 6 divided by the cosine of 40, 7.8324437336. I'm going to round that to 7.8. Our hypotenuse is 7.8. The only thing left to do to solve this right triangle is to find the opposite side now. Like we talked about in class yesterday,
There are a bunch of different ways where we can actually find the opposite side. I think the easiest way for us, the way that we're probably the best at, is the Pythagorean theorem. A squared plus b squared equals c squared. I'm going to set up my problem. A squared plus b, 6 squared, equals 7.8 squared. Do a little bit of math. A squared plus 36 equals 7.8 squared on my calculator. It's 60.84. Show my work. Subtract 36 on both sides. A squared equals 24.84. Last thing I need to do is solve. Square root on both sides. That way I can solve. I know I'm running out of room here. That means I can solve that A equals, comes out to about 4.98 on my calculator. So I'm going to say A is about, my rounding, 5. A is 5. I solved, did we solve our right triangle? Well, do we know all 3 sides? Yes, we do. Do we know all 3 angles? Yes, we do. 2 that were given and the one that we solved earlier. That's how we solve a right triangle. One more example before you get to work on your own. In this example, it looks different. This time, we don't know any angles besides the right angle. We only know the 2 sides that were given, the 31 and the 23. Again, to solve, we need to figure out all 3 sides and all 3 angles. I think the easiest thing to do first is to find the missing side. Find our missing hypotenuse out here. To do that, given a right triangle and 2 sides, I'm going to use my Pythagorean theorem again. I'm going to take A, B, C, A squared plus B squared equals C squared. I'm going to call it H. Fix my 2 right there as well. 2. 23 squared is 529 plus 31 squared is 961 equals H squared. Add those 2 together. 1,490 equals H squared. Solve for H. I need to square root both sides. H equals 38.6 after I round. 38.6 for my hypotenuse. I just found the 3rd side. Now I need to figure out my 2 angles. I know the 90, that's easy. Obviously we're looking for X and Y from our picture. It's up to you which angle you want to solve for first. I think we should solve for X first, because why not? If I use angle X, I need to label all of my sides. We already know that this is the hypotenuse, 38.6, we solved for it. Using angle X, 23 is my opposite, 31 is the adjacent side. From here, it goes to SOHCAHTOA, and it tells me what to do. Since we know all 3 sides, it doesn't matter which function we use. Pick one, go for it, you'll be okay. I choose to use the tangent function. I want to use tangent because the 23 and the 31, those are given to me. The 38.6, I had to do a little bit of work and round. Don't always like to use rounded numbers. Tangent. Let's see. Tangent of X, our angle, equals the opposite over the adjacent. There's our setup. From here, like we've been saying, if we're looking for the angle, angle X, we need to use our arc functions. Our arctangent on both sides. That way we can get our X equals the arctangent of 23 over 31. Plug that into our calculator. I get 36.57303098. I'm going to round that to my nearest whole degree, 36.5. The 5 tells me to go up to 37 degrees. Angle X is 37 degrees. almost done solving my right triangles. We already said we found all three sides. Now, looking at our angles, we have two. We have our right angle. We have 37. We're missing one more. From here, I'm going to take 90 plus 37. I'm going to get 127. Our whole triangle is 180 degrees minus 127. That should give me 53 degrees is left over. 53 degrees. I know my work's gotten a little sloppy. I apologize, but it's all there. You guys can do this. Good luck.